Welcome to Maths for All. I'm Aisling Flynn. This is Functions 1.7, Periodic Functions. Periodic functions are functions that repeat regularly over a constant interval. It describes something that happens in a cycle. It repeats in the same way over and over. And here we have a picture of a periodic function. You can see the same shape, so let's take from the bottom here. It repeats over and over. So what I'm highlighting here in red, that shows one cycle, okay, or one part of the pattern that is repeated again and again. So properties of periodic functions. Its graph repeats at regular intervals. So intervals refers to the distance along the x-axis or horizontal distance. So if we look at our function here, I'm just going to pick this point at the bottom here as the point we're going to track. Okay, and we're going to see when does it start to repeat itself, and it starts to repeat itself here. Okay, so that point repeats itself there, and the interval or the distance over which it took for that point to be repeated is, if we count 1, 2, 3, 4, 5, 6 units. Okay, 6 units along the x-axis or on the horizontal distance. And you can check that if we take the highest point on the function, this peak here, what's the interval to the next peak? So when it's repeated, 1, 2, 3, 4, 5, 6. So yes, this function is being repeated at regular intervals, and we'll continue again to the next one. 1, 2, 3, 4, 5, 6, another 6 to the next peak. Its y values in the table of values show a repetitive pattern, okay, when the x values change by the same increment. So what does that mean? As we go left by 6 each time, so if you keep going in steps of 6, each time we go in step of 6, if we're looking at the peaks, okay, we will arrive at another peak, and the y value that's referred to there is, well, y is here 3. So if I start here at y is 3 and go 6 steps right, I end up at y is 3 again, and 6 steps right again, y is 3. Its cycle is one repetition of a periodic pattern. So I marked that on the previous slide. So one cycle you could take as being from peak to peak. So this valley shape, that could be considered as one cycle. Or indeed, on the previous slide, I went from the bottom to the bottom. That's okay too. So that's one cycle. Its period is the horizontal length of a cycle. So we've marked that already. And in this case, the period is 6. So how long does it take for the cycle to start repeating? Okay, and here there are no units. Okay, often for periodic functions on the horizontal axis you would have time, because it repeats every 5 seconds or 6 seconds or 2 days or whatever. Its amplitude is half the difference between the maximum value, the peak, and the minimum value, the trough, in a cycle. Now what does that mean? Well, basically half the difference. We're looking, where is the center of this signal, this function? Okay, so if you take the top, and where is the bottom? So the top is at 3, we see. The bottom of it, the lowest points are at -2. So halfway between that would be 2.5 boxes down and 2.5 boxes up. So it'd be here. Now if I were, you see that? So 2.5 boxes down and 2.5 boxes up. And if I were to draw a horizontal line here, I could call that like a central axis. Okay, of the function, and the amplitude is the maximum distance from that. So from there up to the peak, or from let's say here down to the lowest point. And in this case 2.5 boxes is our amplitude. Our amplitude equals 2.5. So it's the maximum displacement or maximum distance from a central line, okay, is your amplitude. Okay, so from our discussion on the previous slide, we're going to look at this function here on the right. So clearly it's periodic because it's repeating over a regular interval. So we can say it is periodic. The function shown on the right has a period of. So what is the period? Over what distance does it start to repeat? So let's choose a point on the function. Let's choose the peak here. And when does that repeat? So if we count the units, it repeats after 1, 2, after 3 units. Now just to make sure, let's check again on the next cycle. 1, 2, 3, yes. 1, 2, 3, yes. And to be extra sure, you could choose a different point on the function anywhere at all. So perhaps the very bottom here, its position there is minus 3.5. So if we go 1, 2, 3 units, yes, it repeats after 3 units. So the function shown on the right has a period of 3. Okay, next we have to state the amplitude of the function. Okay, so on the previous slide we see that the amplitude is basically the displacement from a central axis. So where is the center of this function? Well, it stretches up as far as +3, that's the max, and down as far as -1. So what's halfway between those two values? Well, it would be 2 units down or 2 units up. So this would be a central axis, giving an amplitude of 2. Okay, so 2 up or 2 down. Now amplitude is not really used so much in your maths text. We refer to it a lot if you're doing physics or waveforms or something like that. What we talk about in terms of functions in maths would be the domain and the range. Okay, domain and range. So if we think back to previous lessons, domain refers to the input values. Okay, and they're on the x-axis when you plot a function. So these values, when you enter them into the function, what output do they give you? So let's look at the x values for our domain. So this graph shows, now the function does go on and on forever and ever, but what does the graph show? Well, the graph begins at -6. So we see that there. So the input values begin at -6 and they finish at +6. Okay, and they would continue, but this particular graph shows from -6 to +6, and in this case we're using square brackets because that includes those values of -6 and +6. Okay, and then the range we learned refers to the output values, or f of x, and they appear on the y-axis or the vertical axis. So what are the output values of this function? Well, you can see that they go up as far as 3. So here 3 plus 3, and they go down as far as -1. So what section of the y-axis is included as an output? Well, here I'm just highlighting it here, from -1 up to +3, and it includes those two values. So that is the range, from -1 up to +3. So let's look at a few different ones. Is this a periodic function? and the graph shows the number of hours of daylight over a 3-year period. So you know, as we go to summer we have lots of daylight, in winter we have much less daylight, and so on. So let's look at the function. Now the first thing is there repetition over a regular interval? Okay, so if we start at time 0, I'm here. If I go 1 year later to 365, am I at the same place? Yes, I am. If I go 2 years later, so that's 730 days, and 3 years later 1095 days, yes, it's repeating. Okay, this is a cycle. The other thing to check is that the y values remain the same. So let's look at the maximums over 1 year. They remain the same heights, they're not dropping or rising. Okay, and along the bottom the minimums, they're staying the same as well. Okay, so I would say yes. Is this a periodic function? So again, we're looking for repetition. All right, let's take the peak of it, and from peak to peak to peak, is that red distance, is it always the same? So are the horizontal distances always the same? So this looks like 2, 4, 6. So here I am at 3, 6, 8, 10. So that point there is that x value 9, 12, 14, 16, that's 15. Yes, so you can see that they are repeating. That's 20, 21. Okay, so they're going up in 6s. So the spacing horizontally is regular. There's their regular intervals, so that's good. And then look at the y values, or the heights. All the peaks are at +1, and all the troughs, the lowest points, are at -6. That's good. And the rest of the shape appears to be the same. And you can see that one cycle, wherever you choose to start, looks like this. Okay, whoops, that's, or down as far as here. So yes, I would say that's a function. Finally, let's look at this one. Is this a periodic function? A student moving a meter stick back and forth with increasing larger movements. Okay, well, some things appear to be the same. It appears, let's look, horizontal distances, they appear to be the same from peak to peak. However, you can see quite clearly that the amplitudes are increasing. Alright, so the y values are changing. So for that reason, I would say no, this is not a periodic function. Okay, now you try some of that through the quiz and the written exercises, and here's a bit of a glossary.